All right, so let's take a look at the structure of the moon. This is 7.2 structure of the moon. The moon lacks the folded mountain ranges and that we have on Earth. The volcanic mountains that we have on Earth. It doesn't have the plate tectonics. It cooled a lot quicker than the Earth did, and there's several reasons for that. Let's take a look. The moon's higher surface to volume ratio allows heat to escape faster from it because oceans, one of the reasons is the oceans hold a lot of the heat. Um, is no water like that on the moon. Also, some of these, the mountain ranges in that, the little bit of mountains on the moon are from impact craters. Also, the way it cooled off fast. It's kind of like if you leave an apple out in the air, the apple contracts as it cools off, and it causes little ridges in that to form. So that's part of where this came from. As it cooled off, it forms ridges and cracks and that. In you can see it more on some of the other planets also, and instead of just the moon. But being much less massive than the Earth, the moon also has a smaller source of radioactive material to supply heat. Remember, the interior of the Earth is heated from radioactive material. All right. The interior, including the crust, is studied by seismic detectors. We saw in the movie, if you watched the movie with us, that one of the last things they did was put seismographs on the moon. Um, and because of those there, we find it to be inactive. And it has a similar or a simpler structure than the Earth. And we can tell again because of the seismographs that were set on the moon. Surface of the moon, or the regolith. That regolith is that rock debris. Okay, surface layer is shattered rock chunks and powder from repeated impacts, and this forms a regolith and that regolith can be very thick, tens of meters thick. Tends to be a little thicker on the dark side of the moon than it does on the side that we see all the time. Regolith is basaltic in the Maria and anorthostic in highlands. Remember that the Maria, that when the lava did come up on the moon and it cooled, those are the darker areas, and that is much more basaltic in nature. Regolith may extend to several hundred meters in some places, and most of the deeper places where that regolith is a lot thicker is on the dark side of the moon. The crust, the average thickness is about 100 kilometers, although crust is thinner on the side that faces the Earth. Reasons for symmetry is not clear, but may be related to the difference in the gravitational force across the moon, the Earth's gravitational force. We think that the reason the crust is thinner on the side that faces the Earth is Earth's gravity affects it and possibly has pulled some of it off. Because remember, there's not much gravity there. Very few Maria exist on the side of the moon away from the Earth. And the crust is composed of silicate rock rich in aluminum and poor in iron. And we know this from the rocks that we brought home from the moon. The mantle of the moon is relatively thick, extending 1,000 kilometers down, and is probably rich in olivine. And you would know if you took the geology class, you'd know what olivine is. It's a really pretty green mineral. It appears too cold and rigid to be stirred by the moon's feeble heat. Now, I will say too is that so there's not much of a convection current. There's what it's telling us, but some people believe that the moon has a hollow property to it. And why that is when we put down the um, seismographs, uh, when it is hit by a meteor, when it's hit by an asteroid, or when and yes, we've done this on purpose, just like we have done it on Earth with nuclear testing. They've shot rockets into the moon to see what the seismograph picks up so they can tell what the interior and that is on the moon. Um, it tends to ring sometimes like a bell or vibrate like a bell would vibrate. Like those little bells, if you walk up and you hit the plunger and it bing, and it'll keep echoing for a while. The moon seems to do that sometimes if the object that it hits it's large enough. It has a um, property to it that causes it to vibrate quite a bit. And because of that, there's some people that think the moon may be hollow. The core, the moon's low average density, 3.3 grams a cubic centimeter, um, tells us the interior contains a very small amount of iron. Some molten material may be below the mantle, but core is smaller and contains less iron and nickel than Earth's. The relatively cold moon interior is low in iron and nickel content, and slow rotation imply no lunar magnetic field, found to be the case by the Apollo astronauts. So there's really no um, magnetic field for compasses and whatnot to work on the moon. So, and we know this because the astronauts obviously tested this, but that would tell us that the core does not have much iron and nickel like the Earth's core does. And again, this is more geology or earth science to cause an electric field or a magnetic field to be generated in the core. That's it for the structure of the moon. Next will be the lunar atmosphere.